So in this video, we're going to discuss about minimum and maximum phase filters. So we are continuing our discussion on filter types. So there are two kinds of filters which we can define, min phase system and the max phase system or max phase filter. So the basic difference is, okay, a min phase filter has all the zeros inside the unit circle, and a max phase filter has got all the zeros outside the unit circle. That's it. So, but what is the utility? Let's study. Okay, so we know for a stable system, all the poles must be inside the unit circle. So this is the z plane. All your poles should be inside the unit circle for stable system. But the zeros could be anywhere for stability. It could be here, it could be here, it could be here. No problem. Zeros could be anywhere. But now let's see what effect does it have if we keep the zeros inside or outside the unit circle. Okay, so let's take for example this filter which has got a zero outside the unit circle. 1 plus 2z inverse, so it has got a 0 at 2, which is okay at minus 2, which is here. So this is a 0, and it has got a pole at 0.3. So this is the pole at 0.3. So what does this mean now? So if I plot the magnitude response, as you know, your e to the power j omega is increasing is in this direction. So basically this distance divided by this distance. So when it is 0, the maximum ratio, so which is 4, and as it goes here, it keeps decreasing and it becomes very small, right? Less than 1. Now, what happens to the phase response? The phase response here, it will be, if it is here, then it is, if you have to start from here, right? Because this is a 0. When you're here, the phase response is 0. 0 degrees Celsius, 0 degrees. And then when you increase your omega, as your omega is increasing here in this direction, when it finally reaches here, your phase becomes minus pi, right? This is minus pi. So phase is 0 here, and then it becomes minus pi when it reaches here. Okay, now let's look at the effect of moving this circle moving this 0 inside the unit circle, which means basically I replace my 2 by 1 upon 2. Okay, so I have replaced 2 with 1 upon 2, it becomes 0.5. So now the circle comes here, 0 comes here, and the pole is there itself. What happens to the magnitude response? Nothing changes, right? Why? Because, okay, well, there's only a scaling of the factor 2, right? Only a scaling. So if I say 2 times, basically if I multiply this with 2, then it is same as the previous one. Okay, so the magnitude response has got no change. But what has changed is the phase response. When I was here, the angle was something, and when I reached here, the angle was something. So it was 0 here, and when it reached here, it again became 0. Right? So what do we see? The phase variation is minimum. So if you see the previous figure, the phase was varying between 0 to minus pi. So these frequencies are heavily distorted by the phase response. But these frequencies are less distorted. There is some distortion in this area, but that is why this system is called minimum phase system. It causes the least amount of distortion of frequencies. That is the use. Okay, so this is a max phase filter. A max phase filter has got all the poles, all the zeros outside the unit circle, and therefore it causes maximum distortion to the phases of most of the frequencies. But the min phase system, it causes the least distortion, and it has got all the zeros inside the unit circle. Okay, let's see some of other utility or effects. So yes, so minimum phase filters have got minimum phase distortion, so they are very desirable, right? We don't want to distort our signal too much. Okay, and what is the difference between min phase and max phase in terms of implementation or in terms of transfer function? So basically max phase is just a min phase multiplied by an all pass filter. You know what is an all pass filter? It is whatever poles are an all pass filter means whatever, if you have got a pole here, you will get a 0 at 1 upon a. A pole at a, then 0. So basically this is used to cancel out poles and zeros. For example, if this was my min phase system at a, then I multiply with this, if this is my min phase, multiply with this, what do I get? This pole and 0 get cancelled and the 0 moves outside, right? 1 upon a. So that is a max phase system. And this is my all pass system, right? So this is a multiplication operation here. Okay, now now let's see min phase systems. They have got all the poles inside, right? Because it is a stable system, min phase system. Now all the zeros are also inside. What does that mean? It means if I invert it, if I take 1 upon h, 1 upon, okay, let's say hz, this is hz, this is stable and min phase. Then 1 upon hz will also be stable, right? Because for 1 upon hz, the poles will become zeros and the zeros will become poles. This is 1 upon hz. And this is also stable and min phase. So basically, the min phase systems are invertible. Okay, that's it. Thank you very much.